Okay, so we did just get finished talking about simple interest, all right, and today we're going to talk about compound interest. So these are the two main types of interest that you will see in real life situations that you're going to come across, okay? So again, simple interest is basically a percentage of the amount of money that's borrowed or invested, right? So if you take out a $5,000 loan for a car and you're going to get charged simple interest at 5% per year, okay? That's $250 a year, and for however many years it takes you to pay it back, okay? So 250 times 5, if it's 5 years, that's the simple interest that you owe, okay? Compound interest is a bit different, okay? So let's say you take a loan for a car at $5,000 and you pay 5% compounded interest. What that means is this, is that the interest over time, the interest increases a little bit. Simple interest, it's the same amount of interest every year. Simple calculation. With compound interest, a little more complicated. And what happens is you get charged interest on your principal and the accumulated interest. So let's say that you borrow $5,000 and after the first year you owe whatever $5,250. Well, now you get charged interest on not just the $5,000 but on the $5,250. So they're charging you interest on the interest. You see that? And they do that every time the interest is calculated. They charge you interest on your principal plus all the interest that you've been charged up to that point. So it's compounded. That means it grows exponentially. The amount that you owe in simple interest is like a straight line graph. It's like you add the same amount each time. Simple interest. Compound interest, you add a little bit more each time, and so the price goes up quite a bit quicker. So we're going to learn a little bit about that today. So let's read. This is what your book says. It's a type of interest, compound interest, that is calculated on the principal plus any previously or interest previously earned. So what I just said, it's the percent on your principal plus any interest that's already there. Now if you're investing money, that's a good thing for you, right? Because you put in some money and then you get a little bit of interest. And then you make a percentage of that whole thing. And as the pot grows bigger, so does your chunk of interest grow bigger. But if you're paying off a loan or if you're paying off a credit card, I'm not sure how many of you have a credit card or are thinking about getting a credit card. Please use credit cards very, very carefully. If you use a credit card, you have to pay it off right away, okay? Because if you let it sit on there, they calculate interest every single day and it's compound interest, and the interest rate is really high. So they really, really smack you. If you don't pay your credit cards off, your charges go up really quickly, and a lot really quickly. So you got to be careful with credit cards. They're nice and handy. If you can get one, they're nice and handy, and you can pay with just a tap a lot of times. Hey, I'll just tap for that, I'll tap for that, tip, tap, tap, tap. Easy. But if you don't have the money to pay that off, and there's usually a 3-week grace period where you don't get charged any interest, and if you can pay it off in that 3 weeks, you're good to go. But if you leave that money on the card after that grace period, then they go all the way back to when you first put it on there, and they charge you interest all the way up to the date. It's like, no more grace for you. I'm charging you interest from the very day you put that money on there. And then boom, it just gets out of control really quick. So just a caution there from Mr. Maxwell to you guys. Caution, be careful with credit card use. Pay it off right away if you're going to use one. Okay, so that's what compound interest is. As with simple interest, compound interest is stated as a rate per annum. That's per year, right? Remember, annum is per year. If the interest is compounded annually, this means that the interest is applied to the account once per year. But like I just said with the credit cards, it's daily. Daily. It's compounded daily, okay? So it's every day. Now it's a small amount of interest. It's the whole year's interest divided by 365, so it's just a tiny little bit. But it's added daily, right? Not added, it's calculated daily. And so what happens is that grows a little bit quicker when it's compounded more often. So the compounding period is how many times in 1 year that the compound interest gets calculated. Okay? Any questions so far on the first page there? Compound interest, a little bit different than simple. So it's a little bit different, and we have a different formula as well. Okay? So this is the formula, and I want you to turn to page 294 there. This is the formula we're going to use. So let me just zoom in on this puppy right here. And we're going to look at this formula, okay? So let me make my pen really small. So in this formula, the A, do you guys know what the A is? Well, I guess it's right there on your page. It's the final value of the investment, okay? Or if it's a loan, it's the final value of your loan, that is the original money plus interest. Okay? It's the principal plus interest. That's what A is. So this is the final value. The P is the principal, or this is the original value. Okay? Or the beginning value. Now this R, what is the R?
The annual interest rate expressed as a decimal.
Annual interest rate, very good, as a decimal. Okay? And that's going to be very important. Don't, whoops, what is that? No. Expressed as a decimal. So don't put the full percent number in there. You got to divide by 100, right? Because it's percent. Divide by 100, put that number in there. Okay, and then N, what is N? And N is here, and N is here. So what is N? And yeah, you can just look on your paper right there. It's the number of compounding periods in a year. Okay, number of compounding periods in a year. So this formula is one we're going to be using a lot, okay, for these questions. So as long as you know what everything means, and we're going to get some practice using that. So let's zoom back out here. So example 2. Now, basically, I don't know if I need to go through the solution here with you, because I think we need to do this from scratch together. So here's the formula, and they just plug everything into the formula. So I tell you what. Let's get to, where's the next page here? Okay, and this question also asks about simple interest. So I think what we need to do is we need to just go ahead and skip to page 296 here. Let's do some questions from scratch using this new formula. Okay? All right, so number 4, okay, says calculate the final value of a deposit of $5,000. So which one is 5,000 of all of these letters here? R, N, T, I didn't talk about T, but that's the term, the number of years. A or P, which one is 5,000? It's P, exactly, very good. So it's a deposit, so that's your original amount. Okay, invested at 3% per annum or per year. So 3%, that's going to be R as a decimal, we're going to put it there. And it's compounded annually for 2 years.
Is
Okay.
that NP or is that just T?
Well, compounded annually is N. That's 1. How many times per year? It's once per year. Okay, so we're going to fill this in a second. And then, of course, the T is 2 years. Okay. So where is everything going? Well, A, we don't know what that is. So we're going to leave that as A. It says calculate the final value. That is A. But we do know what the principal is, so we're going to put 5,000 right here. Okay. We're going to put a 1. That's just a 1 plus. Now the R we said was 3% as a decimal. So how do you write 3% as a decimal? That is 0.03. 3 100ths. Very good. So I'm going to go 0.03. And how many times per year is this compounded? Once per year. And you put your brackets. So again, that's 1 time per year times, what's the term? Term is how many years you're going to do this for. So the term is 2 years. Okay? Everyone good with that so far? So So that's how we plug that in. So let's do this on our calculator. Okay. Now I think I've already done this already, so that's on the calculator. But this is how this should look. And if you want to simplify some things, you go right ahead. Okay. First, but you could simply do this: 5,000, and you could just use a bracket as a multiplication, or you could do times. And you have to go 1 plus, okay, and then 0.3 divided by 1. You know what that is already, but if this is not 1 and you want to just plug this straight into your calculator, probably use a second set of brackets would be best. Okay, so that you can put this as a separate term inside there. And then close the brackets off again. So this is how I'm going to write this, and then I'm going to go to the power of 1 times 2 is 2. Okay? So you type that into your calculator and just make sure that that'll work, and this is the number that you should get. Okay? So if you get that number, you've typed this in properly and you're okay. If you don't get that number, then you're going to have to look at your brackets or how you type that into your particular calculator. So this is then your answer. The total value is $5,304.50. So we should use our little money signs there. Okay. So let's read the question again. Make sure we've got this correct. Calculate the final value, that's A, of a deposit of $5,000, that's the principal, invested at 3% per year, so that's 0.03 as a decimal right here. Compounded annually, so that's 1 time per year, for 2 years, so that's 1 time per year times 2 years. So this exponent here, NT, is the total number of compounding periods, is what that is. It's the total number of times this interest is calculated for the whole entire term. Okay, and you should get 5,304. So if you were depositing this money into a bank account or savings account that gave you this is what you would end up with after 2 years. Cool, hey? If you were borrowing that money, and this was 3% per year for 2 years, you'd have to pay back $5,304.50. So you would be paying how much in interest? $304.50. So you have to keep this in mind. If you're going to borrow money to buy a car, let's say, and you want to borrow $5,000 and it's 3%, if you pay that back in 2 years, you're going to owe $300 plus in interest. That is just the ability to borrow that money. That's just for the right to borrow that money. You owe an extra $300. Usually, borrowing for a car is much more than this. It's usually closer to 8%. And usually, it's a little bit longer than this. So if you're going to do 8% for 5 years, which is more like a car loan, that's how much you're going to pay back. So I would like us just to do that, because we could do that real quick. Let's make this real here. Let's say I want to know how much a $5,000 loan is going to be, and the actual interest rate is not 3%, but closer to 8%. So I'm going to go at 0.8 here. And you know what? It's usually calculated monthly. So I'm going to put 12 there. Okay? This is a real life car loan for you now. Okay? And so the number of compounding periods is going to be 12 times, it's going to be 5 years. You're going to take 5 years to pay this off because you have no money right now. You're going to borrow the entire amount. You're working at wherever, Sobeys or Safeway, or you're working at a restaurant, or you're working on the weekends at the farm, and you're able to put in a little bit of money every week, and you're hopefully going to pay this off at the end when it's all done. Let's just say that. So if we let this sit for 5 years, this is how we figure out how much in total we're going to owe. Okay? If we don't make any payments on it, we just let that sit for 5 years. This is what it's going to be. So guess what? I am going to do 5,000. I'm going to do 1 plus 0.08% divided by 12. And to the power of 12 times 5 is 60. Okay, so let's see. Looks good. So look at how much you're going to owe after 5 years. Almost $7,500. So 7,449.23. So if you borrowed $5,000 now at 8% interest, compounded monthly, in 5 years, this is how much you'd have to pay back. And your interest, right? The interest here then for your car would be $2,449.23. So you're just thanking the bank for using their money by saying, here's $2,400. Thank you for letting me have my car 5 years ago. So here's the thing. If you're going to pay $7,500 in 5 years, I say try and save up some money now. Instead of getting this cool car right now, get a cool car in 2 years and pay it off so you don't pay the bank anything. Anyways, that's just a little bit of advice, but try and save up some money and pay as much cash at the beginning as you can, and try not to borrow much because you're just paying the bank interest. You don't feel it over time. You don't feel it as much over time, but when you get to the end of that period and you look back and you say, wow, I just gave the bank $2,500, and that's how banks make $4 billion every quarter. Like, it's insane. And why do they do that? Well, because they know how compound interest works. So if you guys know how it works, okay, that's be good for you. All right. So let's do number 3 together, okay? Here we go, number 3. So number 3 says, calculate the difference between the final values of the following 2 investments. Okay, so this is where it's really important, guys. Listen. So we're going to compare compound interest with simple interest. We're going to find out what the difference is, okay? So look at this. We'll call this A. We'll call this B. $4,000 invested 3.5% per year compounded annually, and $4,000 invested 3.5% simple. Okay, so let's use, so for A here, let's use our new formula. Okay, so you guys can do this with me. So let's find out what the future value is going to be. What's the principal? Yeah, $4,000. Oh, excuse me. So what's R? That's the annual interest rate, right? 3.5% as a decimal. 0.035. Very, very good. It's compounded annually, so that's 1 time per year. So that's a 1 there. And this is 1 times 3 years. You see that? So if you're putting this in your calculator, you don't have to put the over 1, and you don't have to put the times 1, right? Everybody see how that, okay? It's going to be a little bit easier to do in your calculator now, okay? So let's go to the other stuff here. Let's go 4,000. Oh, not 40,000. Times 1 plus 0.035 to the power of 3. You see how easy that is? You could also do this little addition in your head too and just put 1.035. You could kind of do a lot of this on your own. Okay, so 4434. Does that make sense? Let's see, 4434. And that's going to be 0.87. Okay, so the difference in final values. Okay, so there's the final value for the compound interest. And let's do part B over here then. This is, who remembers the formula for simple interest? We did that last week. Remember what it is? Got it?
A equals P plus PRT.
Right on. P plus PRT, very good. So let's calculate it over here. A over here is 4,000 plus 4,000 times the interest rate. Is that as a decimal as well here, guys? It sure is. You bet. R, and then T is 3 years. So, do you think this is going to be more or less? You think it's going to be less? Okay. From what we know of compound interest, remember the interest grows quicker. Okay, so yeah, probably going to be less. Let's just see. 4,000 plus, and this is going to be 4,000 times 0.035 times 3. Can do that all at once there, and 4420. 4420. Is that a decimal there? Oh, 0.00. So let's see, were we correct? 4434, 4420. Yeah, a little bit less with simple interest.
So wait, we times it 0.035 by 3?
Yeah, so you do this. you do this whole thing together. 4,000 times 0.035 times 3. That's got to be one thing altogether, and this is the separate thing. Okay? So make sure you can get those numbers. You guys got that? Did you do that? Those numbers on your calculator? You can get that on your own? Okay, so the final value, less with simple interest, and we could calculate the interest, right, by subtracting 4,000 from each. So this is $434.87 here, and this one minus 4,000 is $420. So for interest, I mean, if you're interested in the interest, you can calculate that by you can always just subtract the principal amount. And that's just how much interest you paid. Now, if this is an investment, right, this looks like it's an investment. So the good news is that if you can get a compound interest versus simple interest, you're going to make a little bit more money back. Okay? All right. I was talking to my grade 12s because we were doing something similar to this in grade 12 math as well. And I challenged my grade 12 kids. I said, listen, once you realize how compound interest works, you might be quite interested in trying an experiment. I said, you should get $50 right now and put it into an investment that makes compound interest. And then in 50 years from now, pull it out and see how much money you have. And they're all like, $50. 50 years? Why would we do that? How can you? I'm like, hey, I'll be about 95. You can come visit me in the old folks' home and tell me how much money you made. Could you guys tell me how much money you would make if I told you that $50 for 50 years at, I don't know, let's say this 3.5%. Why don't we use that? Could you guys figure that out? Figure out how much $50 would turn into, okay? And let's use this right here, 3.5% per year, compounded annually. Okay? Figure out how much $50 would turn into in 50 years.
87.
You could guess,
$30,000.
or you could calculate it.
87.
Hint, calculate it. $87? You got $87?
0.5.
Oh, 0.5? $87.5? I think it's going to be a little bit more than
I
that.
got 123.0.
You got 123 bucks? Okay. Shall we? Shall we just calculate this? Let's see if you guys are right. So what's the future value? The principal is $50. We got 1 plus 0.035, and that's once per year. And now, what is this number up here?
That is 3.
That's going to be 50 years, guys.
Oh, we did 50.
50 years.
That's capped off.
Now, did I circle the 3 here? Annually, no. So I'm talking about 50 years. So it's going to be more than 87.
Yeah, my calculator.
It's going to be a little bit more than 120. Okay. Okay, so let's do 50 times 1 plus 0.035 to the power of 50. Look at that. $50 turns into $279. Does that make sense?
$279.
Okay, so let's say, okay, you listen? That's not a whole bunch, but that's better than $50. Can you guys wait 50 years for that?
No.
I don't think so. So let's see. What if that, guys, listen, what if that wasn't compounded annually, but what if it was compounded monthly? So how would that change? Well, let's see. This is going to be now 0.035. It's going to be divided by 12, right? And it's going to be to the power of what? What's 50 times 12?
600.
600, thank you. To the power of 600. What do you think it's going to be? Let's see. Oh, $286. Now, that doesn't seem like much, but look at this. Do you see how this money actually goes up if it's compounded? Look at, it's the same amount, it's the same percent, but do you guys see how this is compounded more often?
Compounded every day.
What if it's compounded every day? Let's figure that out. I'm glad someone said that. So let's see. Instead of, where are we at here? Instead of divided by 12, let's divide it by 3, 6, 5. Okay. And then let's take it to the power of 50 times 365 days in a year. Let's see.
18.
Oh! You get a whole nother almost dollar.
Oh my.
It's not fair, that's it.
Okay, so the more times it's compounded, the more money you get, even though it's just a little bit. Now, listen. What happened? What would happen if all of you, and we only have 5 here right now. What happened if the 5 of you, right, each put in $50? Would that be 279 times 5?
Yes. Cool. 1,390.
Okay. So well, listen. Times 5. What is that? What is that?
1,395.
Okay. Now, wait a minute. What did you say? You got,
Putting our money together.
we're putting our money together.
Only going to go have 150 together.
Hey, listen to this, guys. Very good point. Does it matter if those $50 are each separately growing, or would it be better if you had a larger amount to begin with and let that all grow?
Have that 50.
Wow, this is good. Let's see what you guys, as the 5 of you that are here today for this lesson, let's see what if you put $50 in each. How much is that? $250, right? Oh boy, this is exciting. So instead of $50, guess what we're doing? We're doing $250. Oops. And this is going to be, no, you can't leave yet. Don't leave yet.
It's getting exciting. You got to stay here.
This is going to be, okay, let's say it's compounded monthly. And this is 50 years times 12 months, okay? So $250, that's a big pot, right? Times this to the power of this. Let's see what we get. 1434.
Woo!
Just think about it. In 50 years, you guys could have quite the party with your $50. You could even go-karting or something.
We
50 years. How old will you guys be in 50 years? About 66?
We each only get 280.
67?
We are not.
Well, unless it was somebody steals.
All right. Okay, Nathan, you can go. What do you need to do there?
I have a question about my calculator.
Okay, so we're learning a lot of important things about compound interest, guys. It's good. Okay, so I'm going to give you guys a few minutes to do number 6 on your own. Do number 6 on your own today. Okay, and we'll reconvene in a few minutes and we'll move on. So do number 6 on your own. Go. All right. So grade 11s. This is what you should have had. Remember, this question is actually asking you for the interest only. So this formula helps you solve for the total value. So the interest would be the difference between the total value and the original principal amount. Okay? So this is what your work should look exactly like, just like this. You want to find out, first of all, what your future value is. So we have a principal of $8,000. We have a 2.5% interest once per year for 1 times 5 years. So when you do this on your calculator, you should get $9,051.27. How many of you got that for a future value? I heard that number thrown around. Okay. So if you stop there, it means you haven't quite read the question all the way through, or carefully enough. The question actually says calculate the interest that you would earn. And so this is the total value, but you didn't earn your original amount in this process. So what you have to do is you have to take the total amount that you're going to get minus the money that you put in, and that is your interest. So the actual answer for this question would be $1,051.27. Okay? Good? Everybody understand that one? Okay. Yeah? All right. So as we move on, now example number 3, I just want you to, we're going to take a look at this question. I've already talked about this so there's really not too much that's new here, but let's just see what this question is asking us to do. It says calculate the final value of a deposit of $1,000 invested at a rate of 2.8% per year for 4 years with the following compounding periods. So let's say we have 3 different compounding periods. Do you remember what we said in our previous example about the $50 class gift for Mr. Maxwell? I mean, class investment, right? We said that as it was compounded more often, what happened to the future value? It went up. Yeah, the more times you can actually calculate this type of interest, the more money you're actually going to end up making. So for example, look at A. So if it's compounded semi-annually, that means twice per year. Okay, twice per year. Quarterly means 4 times per year, and monthly is 12 times per year. So look real carefully. It's the same formula with the same principal, with the same interest, but look at, here's 2 times per year. Okay, let me zoom in just a little bit. So 2 times per year, we make this much money in total. Compare that with 4 times per year, we make, look at the comparison here, 1,117, 1,118. So a little bit more money. And then C, compounded monthly, 1,137. So in all, okay, in total here, the more times you compound the money, the more money you're going to end up with at the end. Or the more times your investment is compounded, the more interest you're going to have to pay. Okay? Questions? And of course, you can calculate this just with using our new formula. All right. So I'm going to let you guys have, excuse me, have some time to work on questions 7 and 8. Let's just make sure that we know how many times per year each of these are calculated. So annual is 1 time per year. So N equals 1 for annual. What did we say about semi-annual? N equals 2. Quarterly, N equals what? Quarter? 4. Monthly, N equals, there's 12 months per year. Okay, you guys got it? Okay. All right, so go ahead and do number 7 and number 8. I'll give you a big chunk of time here to do that, okay?